Examine the topology on the left-hand side. What do we have? We have DSW1 as the root bridge with a priority of 28,673. We have these two ports configured as root guard enabled ports. And for some reason, our access layer switch had its priority changed to 20,481, making it the device with the best bridge ID. And as a result, when it sends out its BPDUs, those BPDUs have the best bridge ID in them, forcing DSW1 and DSW2 to transition these interfaces from their designated port status to a root port status. However, since root guard is enabled on those interfaces, instead of transitioning those interfaces from designated ports to root ports and pointing to the new root bridge, they go into the root inconsistent state. Why? Because those ports are not supposed to receive those superior bridge protocol data units. We have set up root guard to stop this from happening. So now they're in the root inconsistent state. Let's examine that in our live environment. Right now, if we examine DSW1, it is the root bridge for VLAN 10. It's currently the root bridge for VLAN 10. We have root guard enabled on our interfaces of gigabit 101 and 102. If we look here, you can see root guard is enabled on 101 for VLAN 10. And when you enable root guard, it enables it for all VLANs on the interface. But let's see what happens now when ASW1 has a better priority. So what is the priority right now? The priority right now is 0 with the extended system ID of 10 for a grand total of 10 for the current root bridge. So ASW1, we'd have to give a priority of 0. All right, so configure terminal. But let's check here the MAC address. Do show span for VLAN 10. Our local MAC address here is 081F. If you go to DSW1, it is 2893. So right away, we can see that if we give ASW1 a priority of 0, since its MAC address is lower than DSW1, it should become the root bridge. So let's go ahead and do that. Spanning tree, VLAN 10, priority 0. So we should become the root bridge, but DSW1, look at that right away, receives that BPU and goes, whoa, no, not a chance. Why? Because I have root guard enabled on gigabit 101, which states if you receive a bridge protocol data unit with a better bridge ID, don't trust it. It's not supposed to happen that way. So we are protecting this root bridge. So DSW1 remains the root bridge for VLAN 10, as we can see here. However, ASW1 does consider itself now the root bridge for VLAN 10. Look at that. So we technically have two root bridges in our topology, which is not good either. We are going to have an issue with traffic flow right now. So we do have to take action to solve this particular problem. And first and foremost, we have to identify that this problem exists. So through the use of syslog messages, as we can see, we understand that we have a port that is being blocked by root guard. But another thing we can do is we can see the information in the output of show spanning tree for VLAN 10. We'll see here that it says our port gig 101 is broken. That's exactly what it says there. BKN for broken. And there's a little asterisk which is saying, look, it's in the root inconsistent state. We have a command called show spanning tree inconsistent ports, which can identify those ports that are in the spanning tree inconsistent state. And in this case, gigabit 101 for both VLAN 10 and 99 are in the root inconsistent state. because ASW1 is sending those superior bridge protocol data units out of its interfaces, and DSW1 is receiving those superior BPDUs inbound on gig 101. So it places the interface in the root inconsistent state. We'll also see that DSW2 has done the exact same thing as well. So show spanning tree inconsistent ports, because gigabit 101 and 102 are also set up for root guard as well. So what do we need to do to solve this particular issue? Well, first and foremost, we need to find the offending device. So we can use other commands such as show CDP neighbors, follow the spanning tree path back out gigabit 101 to figure out what is going on in the topology. And we have to, at that point, remove whatever it is that is causing those BPDUs to be sent. So in this example here, it's simply the fact that ASW had a better bridge ID. So it's a matter of going to ASW and changing its bridge ID back to whatever the default value is, or back to whatever it's supposed to be set at if it has been manually changed within the environment to a different value. So just simply reset ASW's bridge ID. But let's say there was a PC in operation by a malicious user, and they had software that sends out these BPDUs, and they're just doing it to mess up our topology. Well, in that case, we have to remove that software off that PC. Maybe it's a switch that's been added to the topology by accident by somebody who's studying for their certification exams, or maybe because they are trying to implement something in the real world, or they're practicing, so they connected a switch to our topology and it had a better bridge ID, and it's causing this problem. So we find that device, remove it from the topology, and once we do so, recovery is automatic. We don't have to do anything after that. Just remove the offending device and root guard will unblock. Let's take a look at that. We go back to ASW1 and we can type in no spanning tree VLAN 10 priority 0 on ASW1. And if we go watch DSW1, we should see a syslog message here shortly that says it has recovered from the root inconsistent state. So there's the syslog message. It says spanning tree. It's a severity level of 2, root guard unblock. Root guard unblocked port gig 101 for VLAN 10. So now if we look at the inconsistent ports, it's no longer in the root inconsistent state.